My name's Erik Olson. I'm a program manager on Microsoft's .NET Framework team, and we're going to be talking today about all of the relevant ASP.NET security topics. I recently had a lunch with one of the members of the scientific research community, and he said two things that really struck me as being interesting. The first thing he said is that security is fundamentally hard. It's a lot harder to protect things than it is to tear them down. It's a lot easier. Another way of saying that is it's a lot harder to build stuff than it is to destroy it. Well, the other thing he said is that security can only be effectively learned through apprenticeship. In other words, the school of hard knocks. You need to go out and make some mistakes and figure out what you're doing and figure out how to do it. Well, part of what I hope to accomplish today is to kind of guide you down the path to ASP.NET security and show you that we've done a lot of work to make developing secure web applications a lot easier than it used to be, and to tell you how to use the security infrastructure that we've got in the hopes that you can tap dance around some of the landmines in the path and avoid some of the common pitfalls that developers make when writing secure web applications. So the topics that we'll cover today, we'll start with the survey of ASP.NET security. I'll talk about some important things like process identity, thread identity, configuration, and something we call the HTTP runtime, or a server-side event lifecycle that lets you basically handle interesting security-related events and have a chance to run your own code during those events. We'll then look at authentication specifically. We'll talk about the built-in support ASP.NET has for authentication, and then talk about how you can customize that or go to a more advanced level if your application needs to do that. We'll then talk about authorization, or once we know who somebody is, what they can do. Again, we'll talk about the built-in support and some strategies that you might use to access control inside of your application. And then we'll explore some custom approaches or some more advanced topics such as writing business logic to enforce access checks and things like that. We'll finish it up with a look at something called code access or evidence-based security. We're used to talking about security in the sense of a user or a request entity. Who am I and what can I do? There's an additional security concept in the common language runtime that basically says this piece of code has these permissions and it can do these things. And it doesn't matter if an admin's driving it or if a guest is driving it. The code itself is constrained by virtue of what the code is. And we'll talk about how that plays into the ASP.NET security system and how you can use it to constrain web applications as well. I wanted to start with a few words about the design motivations for ASP.NET and the security support. The primary goal was that ASP.NET should be extensible and customizable. We build it to work great with platform security services. That's usually the no or little code approach. Basically, let the platform take care of authentication, let the platform take care of authorization. If you do need to do additional things or integrate with legacy systems or other infrastructure that you've got, we put the hooks in there so that you can do that in a very natural way that's part of the system. So extensibility was very key to this design. Another thing that was very important was authentication scheme transparency. Or in other words, if I write an application that, say, uses basic auth, or I write another application that uses, say, SSL and client certificates, most of my application code should be identical, and the part that interfaces with the user identity and the access checks shouldn't really care what kind of authentication I use as long as I have a consistent, stable identity to work from. And so ASP.NET has a programming model that works to support that. And finally, we've done a lot in ASP.NET, and this goes beyond just the security space, to make deployment easier. You may have heard us talk a lot about Xcopy deployment, or this idea that you can basically package up your application and just blast the bits across onto a server using FTP or Xcopy or whatever it is, and basically be done with it. And we have some security support as well for that. Things like being able to actually put access control lists of a sort inside of an XML configuration file and use that for your app. We'll talk about basically fine-grained access control techniques. Most people are familiar with the common technique, which is I check somebody at the gate. I've got an ACL on a resource, or I might do some kind of an authorization check when I first run the page, and then I let code run. But sometimes we want to do things a lot more granularly. We want to check for every method that we call, or we might want to give somebody a different display based on what roles or groups they happen to belong to. And finally, we'll talk some more about evidence-based security. We touched on that before. Let's start with a quick look, though, at one of the things that ASP.NET has to support some application layer security. So I'm going to run just a simple page here. It's got a form for an email address, a phone number, and a zip code. And I'll just go ahead and enter some information into this form. and go ahead and submit it. So this form actually has a really egregious security hole. Does anybody know what it is? You can take a guess here. So what I've actually done here is I've taken content that came in from the form and I've echoed it back here. And this actually opens this application up to something that's known as a JavaScript script attack. It can be JavaScript or other kinds of script. It's a script injection attack. So I've let somebody put data into my page. I've echoed that data back without validating it or escaping it, and now I'm letting them essentially run JavaScript in my context. So this is a really, really common web application flaw. Mike Howard is going to be doing a talk later in the day called Writing Secure and Hack-Resistant Code, where he'll talk all about these sorts of attacks and how, as a developer, you can write code that protects against them. I'm going to show you one quick way to make this easy with ASP.NET. So I'm going to go to another version of this page that uses a set of controls called ASP.NET validation controls. And these controls can basically be wired up to point at form input data and ensure that it looks the way that you want it to look. You can canonicalize it, you can make sure that it contains things like just digits or just alphanumerics, or we have a powerful regular expression parser built into the framework that basically lets you kind of permute data into any way you want it to look. So let's go ahead and I'll try the same technique using the validation control. This time if I try to submit the form, you can see that my validation control said, hey, this isn't actually a valid email address. I've used a regular expression to go in and say valid email addresses look like this. They're basically letters and digits followed by an @ sign, followed by a dot, followed by more letters or digits and dashes. But I won't let things like scripts in. So validation controls can't solve all your problems, but they are a good technique. And the point that I'm trying to make here is think hard about your web applications. Think hard about where your data comes from and what you do with it. And ASP.NET has a lot of support for making that an easier process using things like validation controls. Okay, let's start by talking about identity. So we have two basic sets of identity that we're going to talk about. We'll talk about the process identity, which is inside of ASP.NET, we've got a thread pool, and all these threads get some basic identity. When a thread gets scheduled to perform a request, and we'll talk about this in the next slide, it may take on a different identity for the purposes of processing that request. So what we're talking about here is the identity of the process, or what everything starts out as. There are two stories here. There's one path for Windows 2000, another path for Windows.NET Server and IIS 6. The Windows 2000 path is that ASP.NET essentially runs as a child process of IIS, which means that it inherits the IIS identity. This is system by default. It's a very powerful administrative account. It is not appropriate for all web applications. Because of that, ASP.NET ships with a much weaker account called the ASP.NET account. You can configure the use of this account for your application using the section called the process model section inside of configuration. I'll show you where that is in just a moment. Basically, you just say, I don't want to use system, I want to use the machine account, and ASP.NET will run with this other account. On Windows.NET Server, IIS has a new process model that lets you basically run different applications in different process pools and select the identity used for each process pool. The default identity of all of these process pools is an account called Network Service. Network Service is a very weak account. It starts out being very secure, doesn't have very many privileges, and so it's a very reasonable way to start running applications. And this is what you get, again, by default on IIS 6. If you want to alter the identity for a given application, you can do that as well. So the recap here is on Windows 2000, you start as system, unless you configure it to run with a weaker account. On Windows.NET Server, you start as network service. So we talked about the process here. What am I actually going to be running code as when I start processing a request? So there's a server application concept known as impersonation. Impersonation basically means a server application takes on the security context of the authenticated entity making the request and runs with that temporarily. This is configurable in ASP.NET. You can choose to impersonate, which means that you'll be running with the security context of the authenticated or the anonymous user, or not. If you don't impersonate, you'll always be running code as whatever the process identity was. So again, on Windows 2000, if you don't impersonate and if you don't change the default settings, you'll be running code as the system account. If you want basically ASP-compatible behavior, you can go ahead and enable impersonation. This can be done for an entire machine. It can be done for just one application, or even for just pages or directories. Using this identity directive, you just say identity impersonate equal true. This means that whoever is the request entity, whether it's an authenticated user or an anonymous user, in which case it's usually the iUser account, you'll be executing code as that account on that thread. So why may you want to or may not want to impersonate? Let me give you a couple of metrics to help you make that decision. If you want the operating system to do access checks for you when you attempt to access resources, you do want to impersonate. You just enable impersonation. Things work pretty much the way they worked in ASP. When you say try to access a file or a component or something, the operating system will perform its access check against the impersonated identity, and you're good to go. You may not want to impersonate if you're trying to build a trusted subsystem kind of application where you authenticate the user at the gate and then you go do a bunch of privileged things on their behalf. One more thing to realize about impersonation is that it's specific to a given thread. In some very advanced applications, you might want to do something like start some work on the main thread and then kick off a bunch of asynchronous processes that end up running on other threads in the thread pool. Those operations will run on those other threads with the process identity. So be careful with that. If you want to preserve the original identity, you either want to do your access checks on the main thread or take the information that you need along with you so that you can do it on the other threads that you're doing your work on. So again, impersonation is optional. If you enable it, it works pretty much like ASP. You run as typically the iUser account or the authenticated user account. If you don't enable it, you run as the process account, meaning system or network service or the ASP.NET account. This is a little snippet of code that belongs in every developer's toolbox, and it basically says, right now, who am I running code as? What's the security context on the current thread? So it uses a class called Windows Identity and a method called getCurrent. getCurrent goes and pulls the security token off the thread and builds a Windows Identity object based on that. You can find out the name of the account using the name property. If you actually want to get at the token, you can use the token property. It's of type int pointer, and you can pass that to other APIs that want to work with tokens. So this is something, if you want to pull out a bit of code and find out what am I actually running this code as, am I impersonating, am I not impersonating, who is the code running as, this is a great way to do it. Let's go take a look at how all this works inside of an application here. So I've got a simple page here that I'm going to request using basic authentication, and it's going to spit back some things about the request entity. It's going to say who the authenticated user was, and that's the first line here. It's going to say what the thread identity is, and that's the second line. So in this case, the request entity and the thread identity are the same. This means that I'm impersonating, right? And then I've got a bunch of role checks going on here. So we'll go look at the code for this and then make a couple of configuration changes and request the page again and see what the difference is. So this is the configuration file for this application, and you can see that I've got identity impersonate equal true. We're going to go ahead and change this to false. And then we'll actually go look at some code, and then we'll request the page again. So the code inside of the page does a couple of things. It gets the authenticated username here. This is constant regardless of whether or not you're impersonating. So ASP.NET will always tell you who the authenticated user is. If it's an anonymous user, there won't be a name. The name will be empty with this user.identity.name. We'll then use the snippet of code that we just talked about to actually pull the token off the thread and find out what the security context is of the current thread. And then I've got a bunch of code down here that calls a helper method that just checks for some common Windows roles. One note of caution here is that basically the way the role-based security inside of the common language runtime works is that it does everything with strings. We'll be talking about an interface called iPrincipal in a little bit. And iPrincipal has a method that lets you determine if somebody's in a role, and you pass a string to that to determine if they're in that role. And so when you use Windows groups, you need to use fully qualified names, whether they're domain groups, whether they're local groups, or whether we've got some of the standard built-in groups here. If you're doing this programmatically, there is an overload It basically lets you use the commonly defined ones. It's more localization friendly, and it uses a class called Windows built-in role. Let's look at the helper method here. It's going to call user.isInRole. User is this iPrincipal class that I've been talking about. We'll take a detailed look at this interface in just a couple of minutes. And we're going to use the role name that we passed in, and then we'll just set some text to say whether or not the request identity is actually in that role. So we've changed the impersonation on this page, and let's go ahead and request it again. And this time that you'll see that the identity will be different from the thread identity, and the thread identity in this case will be running as the default here, which is system, as we talked about before. So remember, we've got a process identity that determines what all the threads start as, and that's what we normally run code as. If we then decide to enable impersonation, we will temporarily run under the identity of either the authenticated user or the anonymous user. If you've played around with ASP.NET, you've noticed that lots of ASP.NET is controlled through these XML configuration files that can be scattered hierarchically throughout the web application hierarchy. These come with a really powerful semantic that allows applications to customize their behavior and deploy it along with their application. So you have a lot of control over what your application looks like. This is great for application writers, and sometimes it's not so good for administrators. So ASP.NET has a facility that allows administrators to make policy decisions on a machine that can't be overridden. And we do this through something called configuration lockdown. This is not specific to security settings. It can be done with any kind of configuration setting in ASP.NET. It's most useful for security settings, though, so we'll talk about it here. The way that you do this is that you use this config directive called location, and then you say path equals something, and then allow override equal false. Then anything inside of that location directive becomes immutable from that point on. And if I attempt to introduce configuration that changes one of those things, the application will get a configuration error before it runs any code. The application never gets a chance to run, and the developer of the app gets a message stating something like, hey, you tried to override the identity thing, that was locked down, you can't do it, or you attempted to override whatever it was that was locked down. So if you're an administrator of a shared server, or if you're just somebody that's trying to make sure that developers can't change configuration out from underneath you, you can specify what you want the policy to be for the scope using this functionality. And I suggest that you think hard about your site and what makes sense to lock down or what makes sense to let applications control. The path specifier here, I want to spend just a moment on this. This can be basically any URL. So you can point it at a particular page. And this is a great way to say, for example, that I want this page to be accessible to anonymous users. It can also be used for things like sites. So I can use a site name here, location, path equal, default website would mean that any code running in the default website would get these settings. If I use an empty string, location, path equals, quote, quote, that applies to every site on the box. So if I want to make one policy decision in one place, I just want to say location, path equal, empty string, whatever my policy is, and then that's immutable from that point on. So configuration, make sure that you think hard, especially if you're deploying a shared server, about decisions that you may not want to have overridden on the machine, and then go ahead and lock those down accordingly. We're going to be talking today about authentication and authorization events a number of times, and so I wanted to spend a second talking a little bit about the ASP.NET request engine. Basically, when a request comes to ASP.NET, it comes into IIS, and through a little bit of native code that's running there inside of an ASP.NET ISAPI extension. It then gets handed off to the ASP.NET runtime inside of managed code, and we start an event lifecycle that fires for every request, regardless of whether it's a page, a web service, a handler, or whatever. Any ASP.NET content goes through this same request lifecycle. You can hook various events inside of the lifecycle and play along like you're part of the system, and that includes all of the security events. And there are two ways that you can do this. You can write a module, and we'll show some examples of that, or you can wire up events inside of a global.asax, which is an application logic file, kind of like global.asa if you're new to ASP.NET. There's no functional or performance difference between the two approaches. You really can go with whichever one you prefer. The only real reason to write an HTTP module is that you pre-compile it and you can reuse it across multiple scopes, whereas the global.asax file is specific to an application that gets dynamically compiled. Again, same functionality, same perf. It's your choice. There are a lot of events, and I'm not going to make you listen to me talk about all of them. I'll just talk about the security ones today. The important ones here are authenticate requests, followed by authorize requests. So again, in the authenticate request event, we figure out who the identity of the remote user is, if there is one. It might be an anonymous request. And then we hand it off to authorize request to determine whether or not the authenticated user can get access to the resource. After a couple more events, we have the handler executing. Again, this could be a page, a web service, a custom handler, whatever it might be. And one more really useful event for security is the end request event. We'll see some examples of this later, but a really common strategy is to do something in the authentication or the authorized request event, and if that fails, short-circuit the rest of the event lifecycle, do something in on-end request, and redirect the user somewhere else to a page saying, hey, you don't have sufficient access rights, or you need to talk to an administrator, or whatever else. This is, in fact, how ASP.NET implements our forms authentication module and a couple of other things. And I'll show you some samples of how this can be used inside of application code in just a few minutes. Okay, so we'll take a look now at authentication, which is determining who the user is. And I want to start by saying that ASP.NET is an ISAPI extension. The important point behind this is that ASP.NET sees requests only for content types that are mapped to it. So if you want to use ASP.NET security to protect something like a Java server page, heaven forbid, or an old-style active server page that you haven't converted, ASP.NET will never see that request. So it's got to be content that ASP.NET owns or it won't see it. You can map things like static files through ASP.NET. It's not as fast as serving them directly through IIS, but if you've got some small amount of static content in your application that you want to use ASP.NET security to protect, you can do that. There are basically four big buckets of ASP.NET authentication. The first one we call Windows authentication, and this boils down to a configuration directive called authentication mode equal Windows, and we'll take a look at these in just a minute. This basically means IIS did it. Whatever it is, IIS did it, and that is a lot of authentication types. It could be basic auth, digest auth, NTLM or Kerberos, or certificate-based authentication over SSL. IIS 6 in Windows.NET Server adds a couple of additional authentication types. Built-in support for passport authentication is there as well. But basically, Windows authentication means that IIS does the authentication before ASP.NET ever sees it, and it produces a security context at the end, and ASP.NET basically builds the authenticated user information, and if you're impersonating the impersonation context, off that information. The second mode is called forms-based or cookie authentication. This is a common web application paradigm on the internet. It basically means that you collect credentials inside of some form, and in the ASP.NET implementation, your application has to validate those credentials. You say whether or not they're good. If they are good, you call ASP.NET and tell them, hey, I authenticated this user. Go ahead and manage this authentication session for me. And we'll be walking through some advanced samples of forms of authentication in just a minute. ASP.NET has out-of-the-box support for Microsoft's passport authentication. More about that in just a moment, too. And the last big bucket is something called custom authentication. And this basically means that your application is signing up to do all of its own authentication. Usually you do this by handling the authenticate request event that we saw a few moments ago, doing whatever authentication it is that you need to do, and then producing an authenticated principal object, which we'll talk about in a moment too. So the four big buckets are Windows, which means the platform or IIS took care of it. This is the no-code way to go. It's definitely, if you can get away with this, this is what you want to do. Forms-based authentication, passport authentication, or custom authentication. I just wanted to say one more bit about Passport here, and that is Passport is a single sign-on service. I'm not going to spend a lot of time talking about what Passport is. I did want to say a little bit about what ASP.NET does with it. So in order to use ASP.NET's Passport support, you need to go to www.passport.com and download the Passport SDK. This installs on your machine a bunch of COM objects, collectively known as Passport Manager. And ASP.NET wraps those objects and makes them look like any other ASP.NET authentication provider. So it makes them easy to use, uses the same pattern that we've been talking about in other places, this principal class, the identity class. Basically, there are a couple of common interfaces that ASP.NET wraps through a single class called Passport Identity. So Passport Identity basically has all the functionality that you need to interact with Passport. If you want to use this, you say authentication, mode equal passport, then you go ahead and start calling methods on the Passport Identity class to do whatever it is that you want to do, to emit the Passport logon UI, to find out what the authenticated user is, maybe what profile information they have, or whatever it is that you want to do. Okay, so we'll talk a little bit about forms-based authentication here. The basic idea behind the forms-based authentication support in ASP.NET is that it should be really easy to implement. We tried to take most of the work out of doing this out of developers' hands so that they can focus on their app code rather than trying to write the same security code that every application that uses FormsAuth uses. So that said, we do have a number of advanced places or advanced customization techniques where applications that want more control over the process can hook in and do things. And I'll show you how you might do a couple of those things in just a minute. But the basic steps to implementing forms authentication are that first you typically configure IIS to allow anonymous users. You don't have to do this. IIS will always see the request before ASP.NET gets it. If you want to double authenticate someone for whatever reason, and I've seen a few folks do this, then you can configure require authentication in IIS too, but typically you say let anonymous users in, and then ASP.NET will handle the authentication through FormsAuth. So we've set up IIS, and the next thing that we really ought to do is use SSL to protect your Forms authentication cookies. I can't stress this enough. The nature of the internet is such that if you use cookies, they will be stolen at some point. Count on it. And the only really effective way to mitigate the risk is to use SSL everywhere you use an authentication cookie. You can do this really coarsely by saying, hey, my whole site is SSL, or you can do it with more granularity by saying, I'm only going to use an authentication cookie, and therefore I'm only going to use SSL for a given subtree of my site. And that's a valid strategy too. Be careful with that if you do it. Don't inadvertently let things go out of that SSL thing that might have a cookie attached to it. I'll talk about how you can configure the paths for cookies in just a minute. But I just wanted to say, if you're thinking about FormsAuth, make sure you're thinking about SSL as part of your planning. Okay, so we've got IIS configured. We know we need to use SSL, and now we're going to go ahead and configure ASP.NET Forms authentication. We then write up the logon page, which means that we produce whatever UI that we want to use for the app. We figure out how we're going to validate credentials, and I'll talk about some strategies for that in just a minute, and then we're good to go. So here's how Forms authentication works. Let's say that we have a request come in to an application that's protected by FormsAuth. It doesn't have a valid Forms authentication ticket. ASP.NET will look at this. It actually handles the authenticate request event to do this and redirect it to a configured location where your application has written your logon page. So that by default, this is login.aspx. So your app runs its logon page. The user reads it, and hopefully they enter their credentials, post back the credential data to the application, which then goes and validates the credentials. This can happen by, say, calling against an Active Directory, by calling into a SQL database, or wherever your credentials happen to be stored for your given application. If authentication succeeds, you call back into ASP.NET to say, I just authenticated John, go ahead and give him an authentication session. ASP.NET will issue a cookie which is configurable for lifetime and content and various sorts of things like that that defines the authentication session, and can optionally redirect the user back to the URL that they originally requested. This time they'll have the valid authentication ticket and access will be granted. You can control the lifetime of these tickets in a couple of different ways. One simple way I'll talk about in just a moment. You can basically define the session for which, the amount of time for which you want the authentication session to be valid. So let's talk about how we configure Forms authentication here. I'll start first with the name of the cookie being used. We have a default cookie name here. If you want to have different applications on the same machine have discrete cookies, you need to configure these things independently. Otherwise, everybody gets the default name and they all share. The login URL just says, where do I redirect folks to in order to provide the logon UI. This can be relative or absolute. The protection attribute says basically what does ASP.NET do with the forms authentication ticket. The default is this all attribute, which means that ASP.NET will encrypt it with the strongest form of crypto that we've got available on the machine. We'll try triple DES. If it doesn't have 128-bit crypto on the machine, we'll fall back to just standard DES. We then add a keyed SHA-1 HMAC to ensure that the ticket itself is valid and append that to the end of the ticket. This is what protection equal all means. If you are using forms authentication for some really weak personalization purposes, something like, hey, my favorite background color is green, and we really don't care about the security of this, you might want to dumb the protection down by just saying, go ahead and just issue clear text cookies that don't have validation max, or even just do clear text cookies with validation max. If you do nothing, you get the strongest form of protection available, and that's the right thing to have happen for most applications. The timeout parameter basically is an integer in minutes that says how long does this cookie session last for. ASP.NET slides this timeout for you in the same way as it does sessions. You can control that behavior if you want by overriding the forms authentication event, but by default it does slide. So what this says is this ticket is good for 30 minutes from the last time it was used. And if you want to cut that down, you can do that as well. If you're not going to use cookies over SSL, and again, I really recommend that you don't do that, but if you're going to do it anyway, you want to turn this timeout down as low as you can stand so that the lifetime of the cookie is as short as possible. And that way, if it does get stolen, it's not good for as long as it might be. The final property here is the path. So all cookies in ASP.NET get issued with a default path of /, which means that this cookie gets sent back to the entire machine. The reason that ASP.NET does this by default is that browsers are strictly case sensitive when they send back cookies. And if you issue a cookie for, say, the foo app with all lowercase foo, and someone types in uppercase foo, browser won't send the cookie back. So this is a problem that's not easy to solve, but basically what you want to do with forms authentication is think about the scope that you want the cookie to be issued to. / may be appropriate if your entire site needs authentication tickets and you're using SSL everywhere. It may need to be more discrete, so you can set the path that you want to use here, or actually you can set the path at runtime as well. The key idea here, though, is to think about the scope of the authentication ticket, make sure that you're sending it to the right places, and that you've appropriately protected the right places within that scope. One more bit of configuration here, and that's the machine key section. So basically the machine key section says what does ASP.NET use to encrypt and do the validation for these cookies that I just talked about. And the default behavior is that ASP.NET uses some cryptographically strong random means to generate a bunch of goo that's your ticket, your key for your ticket, and then we store that inside of the LSA, which is a local security authority, and it's a safe place to store data. Well, this works great for any single machine, but if you want to use forms authentication across a web farm, I hope you can't rely on us generating the same random data in more than one place. So if you want to use forms auth across a web farm, you need to have a coherent, synchronized view of this particular section across the farm. There are two things. There's the validation key, which basically says, what is the salt that I add to the message authentication check? And the decryption key, which says, what do I actually use to encrypt and decrypt the forms authentication tickets? We don't use this for anything else. It's just for forms auth. And let me show you a sample of how you might actually go and generate this in a reasonably strong way if you're going to configure this across a farm. So I've got a little bit of code here that generates these keys, and I'll run it for you in just a minute to show you what it produces. But what I want to point out is that I'm generating the keys randomly using the crypto API random number generator. So this is kind of the best way on a Windows machine to generate random data. It has the best chance of being actual, random, hard to predict sequence of bytes. So I go ahead and create this RNG crypto service provider, and then all I need to do is declare basically a byte array of the number of bytes that I want, and then call get bytes. So it's really easy to use. That fills it with my random entropy, and I got a good random key that I can use. And then I'm just going to convert it to a hex string and dump it out. So let me just go run this little utility. I'm not sure if folks can see that or not. But basically what this does is it dumps that machine key section. So I've got validation key equals and then some really long randomly generated key. And then decryption key equals down here. And again, some really long randomly generated key. So if you're going to use forms authentication across a web farm, this is a pretty reasonable way to generate a good, strong key that you can then copy and paste across the rest of your farm. Okay, so we've talked a little bit about configuration. We've talked about setting up IIS. And now I'll talk a little bit about the forms authentication APIs that you might use canonically inside of your app. The first thing to point out is that these all live in the forms authentication class. So if you want to go browsing through namespaces, you can see what's inside of the forms authentication class for your use. The one-stop approach is called redirect from logon page. And what this basically says is I've authenticated John, give him a ticket, send him back wherever he came from. So he originally requested, say, the default page. He got redirected to the logon page. ASP.NET remembers the original request for you and will redirect him back with this method. Get off cookie says create a valid forms authentication ticket, put it in a cookie, and then give me the cookie and don't do anything else with it. So I might want to set additional properties on the cookie. I might want to set, for example, the secure bit, meaning that the cookie can only be sent back over SSL. I might want to change the path on it. I might want to change the expiration on it. Whatever it is, I get a chance to do it here, and then I have to add it to the outgoing cookie response collection. And if I want to do a redirection, I need to manage that myself. Set off cookie is middle ground. It actually creates the cookie, adds it to the outgoing response, but doesn't do a redirect for you. So basically, you can do a lot more than this too, but these are the three common methods that you might use. Let ASP.NET do everything for you, have a lot of control over the cookie, or just let ASP.NET set the cookie and manage the redirect, if any, by yourself. Okay, so let's actually look at a couple of demos using forms authentication. The first demo that I'm going to show is basically a very simple page. You can see that I'm not great at providing a logon UI. It collects an email address and a password, authenticates the user, and goes and does a role lookup. It basically says, hey, I just authenticated John. Let me go find out what roles John belongs to. And this application is going to determine that John either belongs to a guest or an admin role. Once it determines that John belongs to a role, it's going to remember that and stuff that information inside of the authentication ticket. On subsequent requests, we'll pull the role information back outside of the authentication ticket and use it to make role-based security decisions later on inside of the application. So I'll go ahead and walk through the app once, but then we'll actually go look at the code, which is a lot more interesting. So I've logged onto the page. You can see that John ends up being a guest inside of this application, not an admin. We'll sign out, and we'll go see how we did it. So we'll start with a look at the logon page. And the code that we're going to look at is the event handler that runs on the server when someone clicks the logon button. We'll walk through a number of things here. The first thing is that we'll call some business logic that tells me whether or not this is an authenticated user. So in this case, we're just using the values that the user supplied for his email address and his password, and we'll go and compare them to some database that we've got of authenticated users. If it ends up being an authenticated user, we'll create an instance of a class called a forms authentication ticket. This is the class that models a forms authentication session. We essentially take this ticket, linearize it, stuff it into the cookie, and then pull it back out. So the stuff inside of this forms authentication ticket is really what's inside of your authentication ticket as well. It has a version. This is just used for application-specific purposes. ASP.NET doesn't do any processing on this field. A username here, and again, we're just passing the email address in this case. The time the ticket was issued, the time in minutes that the ticket expires. So we'll say this one's good for 30 minutes. Whether or not you want the cookie to be persistent, and I'll talk more about that in just a second. And finally, some application-defined data. Now what we're doing here is, again, calling into our business logic, and this is going to go do the lookup that I talked about that says whether or not John is a guest or an admin, and it will return me a string that says guest or admin, and we'll take that string and stick it inside of the authentication ticket. So back here to this persistence issue. by default, ASP.NET will issue a cookie with no expiration. And what that means is it stays alive until the browser closes. So usually your authentication session lasts until it times out because of the timeout property, or until the browser closes, whichever comes first. Some folks will want to actually use this forms authentication mechanism for persistence, things like personalization. I want to be able to say, remember this login on this machine and then send it back over time. You can do that by setting this to true. I want to make sure everybody realizes that when you issue a persistent cookie, it doesn't time out. So what you've basically said here is that this cookie is good forever. If someone happens to steal it, they can replay it forever. So you only want to do this in cases where you know that you're protecting the site appropriately with SSL, or where it's some low security thing where you don't care. Again, it's just personalization for colors or some other data that's of inherently low value. So I've got a forms authentication ticket here, and I'm now going to create a cookie with it, and I'll first call a helper method called formsauthentication.encrypt and just hand out my ticket. This is an ASP.NET method that goes, encrypts the cookie, puts the validation back on the end of it, base64 encodes it, and returns it in the string form that's suitable for stuffing directly into a cookie. So it does all the encrypt work. We also have a decrypt method. If you want to use these things symmetrically, you can. And in fact, if you want to use this to roll your own forms authentication, say inside of a query string or inside of URL munging, you could use these methods to do most of the heavy lifting for you. So we've got our encrypted goo here, and we're now going to create a new HTTP cookie. We'll hand it two things. We'll give it the name, and we're just pulling this name out of configuration. This forms cookie name just pulls the configured value out for this app, and then we'll pass it our encrypted string. We'll add it to the outgoing response, and then we'll just basically try to mimic the default ASP.NET behavior here. We'll see if there's a query key called return URL. This is what ASP.NET uses when it redirects folks for you. If it's there, we'll redirect back to wherever they came from. Otherwise, we'll redirect to some default page. So that's really all there is to the logon page. We created the ticket, we encrypted it, we added it to our cookie, and then we decided whether or not we wanted to redirect folks. We're going to look now at the application file, the global.asax file, and this code runs when the request comes back in with a valid forms authentication ticket. So I've got a little bookkeeping code here that just makes sure that we're actually authenticating folks and that it's actually using forms authentication so that someone didn't reconfigure the app on us. And then we'll go ahead and use current http context.current.user.identity, which means basically the authenticated user for this request. And we'll cast this as a forms identity. Forms identity is a class that has a property called ticket, which is simply this forms authentication ticket that we created inside of the logon page. This is, as I said, gets linearized and just gets pulled back out. It's the same thing that we created on the logon page. We'll create an instance of a class called generic principal, and this is the glue that models an authenticated user. So principal has an identity, which basically says who somebody is and how they were authenticated, and then optionally a list of roles that they might belong to. So we'll go ahead and create this principal with our forms identity that we got from the forms authentication module, and we'll also use this role that we stuffed away here as the information about what roles this user belongs to. So later in my code, if I call user.isInRole somewhere, this is the one thing that it will return true for. So that's one way to use forms authentication in kind of a more advanced way, have a little more control over exactly what's inside of the authentication ticket, what the properties are on the cookie, and doing an encryption yourself. As I said before, you can do all this with kind of one method call by saying just redirect from logon page if you don't want to do all this work. But for apps that want to have more control, here's how you might get it. Let me show you one more forms authentication example here. This one looks exactly the same, but what it does under the covers is it goes and authenticates the user using a Windows account. So this time, instead of just providing an email address, I'm going to provide a local Windows account. I'm going to request the page, and you'll see two things here. One is that I'm authenticated as John, and my thread identity is also John. So what this sample does is it goes and authenticates John, and it gets a token or a security context for John. It then stores that token inside of the ASP.NET cache, and whenever John comes back And while his authentication session is still valid, we'll use that token to impersonate John while we're servicing the request. So this ends up looking like some of the other forms of Windows authentication with impersonation enabled. Take a quick look here at some of the code. There's a little bit more code in this one, so I won't have you look at all of it, but we'll look at a few things. We'll start with the logon page, and again, here's the event handler. Logon click. And I've got some business logic here called an authentication session, and I'm going to call the authenticate method on it, and I'll pass it the username and the password. And this nothing here actually refers to an optional domain or an authority that I want to authenticate against. So let me find the right file here. Let's actually go look at that authenticate event. Oops. Here's the authenticate method. A couple of things that I wanted to point out here. One is that we're using a Windows API called logon user. Logon user is the way in Windows to actually take credentials and to get a logon session. So it returns you a token that represents a logon session for a given user. We're calling this through the C# platform invoke facility. So this is a native code call. It's not wrapped by managed APIs. We're going to call it and provide it the name and the password, and it returns, as one of the parameters down here, a token if it succeeds. So we'll take this token, and if it succeeds, we're going to stick it inside of the ASP.NET cache. Let me see if I can show you that code. We're going to stick it inside of the ASP.NET cache for a given amount of time. One of the things that you can do with the ASP.NET cache is say that this thing is good for so many minutes or some such interval of time. And we've written a little bit of configuration inside of a custom configuration section that says that we'll cache this token for some configurable amount of time. By default, it's 15 minutes. And so what this means is that if John comes back to the app within 15 minutes, we'll pull the token back out of the cache and use it to impersonate him while we're servicing the request. So we'll take a quick look at that code that does that, and then we'll move on to another topic here. So as part of this, I've written an iHTTP module. Again, I said there's two ways to handle all these events. You can do it in global.asax or inside of a module. This one illustrates the module. And a common pattern for modules is that you handle the init method, and inside of init, you register for whatever events you want. So I'm saying here I want to handle authenticate request. This is where I'm basically going to say, is John's token still in the cache, and is his session still valid? And then I've got pre-request handler execute, which is a mouthful, and post-request handler execute. And these two things bookend the actual page or web service that's being requested. And what I'm going to do here is say, on the authenticate request event, I'll make sure that he's still valid and I still have a valid token for him. On the pre-request handler execute, I'll start impersonating. The page or service or whatever will run then in John's security context. And on the post-request handler execute, I'll revert back to the original security context so that the thread goes back to the pool clean. So there's a little bit of code there. I'm going to show you just the code that impersonates and reverts. The code that actually impersonates uses a framework class called Windows Identity. It hands it this token that we stuck in the cache, and it calls the impersonate method. This returns something called a Windows impersonation context, and that remembered the previous token that was on the thread and knows how to automatically restore it for you when you call the undo method. So we're going to say we've got a token, let's impersonate him using this Windows identity.impersonate, and then on the post request handler, we're going to say if everything else went good and we've got an impersonation context, we're just going to call undo, which basically says set things back the way they were before we started this whole process. So FormSoft can be used in a lot of different ways. It can be made to be very simple. You can do a lot more customized things with it if that's what your application needs to do. You can do authentication against databases or whatever you want. Here's one way of showing you how you might authenticate against Windows or Active Directory and actually impersonate the user while you're using your forms of authentication. Okay, so I've talked a little bit about custom web authentication. The basic idea behind this is that you sign up to do the authentication for your application. You do this by handling the authenticate request event. If the user's authenticated, you do what we did in the first sample, which is you produce a valid principal class with a valid identity, and that says, hey, this is authenticated, I'll let the request go through. If they're not authenticated, you can turn the request around. Some scenarios for which you might want to do this. You're doing custom SOAP authentication. Maybe you've got custom encryption or custom SOAP headers that you want to process. This assumes that you're controlling the server and the client, obviously, or that you've got code that's written in collusion on both. You might want to handle this event and do some custom authentication there. Maybe you want to support forms authentication without cookies. ASP.NET does require cookies to be enabled in order for its forms authentication support. If you wanted to roll something that doesn't require that, this is one good way to do it. Or you might want to use it just to customize how one of the existing forms of authentication works. So that wraps up with authentication, and we'll move on to talking about authorization, or basically, now that we know who they are, let's figure out what they can do. There are a couple of big buckets of strategies here for ASP.NET. The first one, and this is like authentication, is the just let the platform do it and don't worry about it inside of your application code. This is a great way to go, and for a lot of applications, this is absolutely the right choice. Whenever you're using Windows authentication, ASP.NET has a module called the File Authorization module that will do an ACL check on the requested resource. So if John's requesting the page, we go and make sure that John actually has the right to read the page that you're requesting. This is independent of impersonation, so however you've made that decision, this ACL check is still done whenever you're using Windows authentication. It's also important to point out that if you're relying on the operating system doing access checks inside of your code against resources, that you will want to be impersonating. Another strategy, of course, is COM+ roles. If you've already written COM+ infrastructure that uses the role-based security there, you continue to use that from ASP.NET. That is also something that typically relies on an impersonation strategy. We have something new that we'll be talking a little bit more about in a moment called URL authorization. This is XML config that basically lets you define your own application level roles and respects those. Custom authorization just means I get a chance to run code or business logic when there's time to authorize somebody, and I can decide whatever it is, whether or not they're authorized at runtime that way. Finally, there's Windows.NET Server, and it includes a brand new authorization framework. There's going to be a talk on this later today. I'm not going to be saying much about it here. If you're interested in drilling down into the details, you should go check that out. It's a very powerful role-based authorization manager. It lets you basically do the best of all worlds. You can do ACL-like behavior, and you can also introduce business logic into decisions. So you can say something like, John can get at this page, and John can commit this transaction, but only if it's less than $10,000 or whatever John's limit is. So it kind of makes the authorization decision a lot more complex and lets business processes play a part in determining whether or not the operation is allowed. So the question was, is that talk today or on Friday? It may be on Friday. It is after this at some point, but the talk is called Windows.NET Authorization if you want to look it up in the schedule. Thank you. Okay, so URL authorization is a series of basically a way to encapsulate an ACL inside of your configuration file. It uses a section called authorization, and you can have explicit allows and denies that either grant or deny access to whatever the resource is. You can make this granular with respect to verbs, so you could treat, for example, get differently than post if you wanted to. And you can use users or roles. There are two meta characters that are important. Star refers to everybody, and question mark refers to anonymous users. So a really common thing to do is this snippet down at the bottom that says, don't allow anonymous users in, deny users equal question mark. If you're using forms authentication or passport authentication and you don't want people to get in unless they're authenticated, you'll probably have one of these statements somewhere like this inside of your application. So one of the things about URL authorization that makes it very powerful is that it respects custom roles. So if you're using something like forms authentication or even Windows authentication, and you have custom application roles, if you create those, and we'll talk more about this in a moment, URL authorization will respect them. So you can say allow roles equal some application set of roles that has nothing to do with Windows roles or groups that you can put inside an ACL, and this will still work in that scenario. And it can also be made to refer to Windows roles and groups. So the last bucket here is custom web authorization, and this basically means, like we saw for custom authentication, you get to handle the authorized request event, and you get to decide whether or not the request goes through. Some common things to do here are per request billing systems. I'll show an example of this in just a moment. Or in other words, we'll charge you for every page presentation, and we'll use the authorization event to make sure that you actually have enough funds in your account to view whatever page you're requesting. Restrict access based on business rules. So let's say that you've got business process rules in place to determine that you get in during the hours of 9 and 5 and not thereafter, or you get in 10 times a day and not after that, or whatever the rules are. This is the chance to run custom logic to do authorization. So let's take a look at some more code here that does that. So I'm going to start with a demo here. It's basically going to show me a page, and it will say how much is in my account. And every time I hit the page, you can see that my account debits. So this page cost me 10 cents, and I've got a bargain basement page here that I can request that's only a penny a peek. And every time I hit that, it'll go down a penny. So what we've basically done with this application is we've handled the authenticate request event, and we've said, hey, the user's requesting whatever the page is. Let's go figure out how much it costs. So we do a lookup, figure out how much it costs, and then let the request go through if they have enough money in their account. After the request executes, we handle the end request event and say, now let's debit their account for whatever they just saw. If they don't have enough money in their account, we redirect them somewhere else, say, hey, you didn't get in. So we'll look at that code in just a second, but I also want to show you that this can work for web services. I've got a little client app here that calls into the same application, but this time it's going to request a web service. So in this case, I've decided to use SSL and client certificates to authenticate myself. So here's the client cert dialog. I'll go ahead and select one of those. We'll make the request. Hopefully it will come back with data. And in this case, it's just using, as we said, client cert authentication in order to do the same thing. It's still the same code running for both the web page and the web service. It just looks at the authenticated user, figures out what their account is, calls into the database, and so on. So it can work for any kind of ASP.NET content. So let's go ahead and take a peek at that app. We'll start with a look at the right app. We'll start with a look here at the global.asax file for this application. So I said before, again, we have HTTP modules. We've got global.asax events. We saw an example before of using the HTTP module. This time I'll show you one of using the application file. So I've got an event handler here for the unauthorized request event. This is the same event that we would have seen inside of an HTTP module. We'll start off by calling some business logic that says whether to ask the question whether or not the current user has sufficient funds to view the page. And we'll provide that with two pieces of information: who the user is and what the request URI is. And I'll show you in a minute how those two get tied together. If they have enough funds in their account, we'll go ahead and let the request go through. Otherwise, we'll set the status code to 403, and we'll call this complete request event, which basically says short circuit the rest of the processing. Don't let the page or service or whatever it is run. Do call any registered end request event handlers and then get out. So our end request event handler is down here, and it says if it was a 403, meaning that we just gave somebody the kibosh, send them over here to some page to explain why they didn't get in. Otherwise, go ahead and debit their account. So the last thing that I wanted to show you here was a custom configuration section inside of this app. I've defined a section here called billing data, and inside of this I basically said that pages cost 5 cents by default. My insufficient funds page is free, and then I've got different prices for some other different pages there. When I call into the business logic, it consumes this configuration data and basically makes a decision about how much the particular request costs. Goes ahead and does its stuff. So that's one way you might use custom authorization inside of your app in order to do something that is hard to do with traditional access control mechanisms. Okay, we've really been talking about role-based security all along here, but I wanted to spend just a moment drilling down on the specifics of how this works. We've seen this a couple times already, but this is an interface called iPrinciple. iPrincipal is basically the glue that defines what an authenticated user for a request is. It has two parts, the identity, which again is who they are and how they were authenticated. And basically, this method's called isInRole, which says do they or do they not belong to a particular role. The two course groups of strategies here are use Windows authentication and let us take care of it for you. We'll take care of populating this information with all of the group SIDs inside of the particular user's token. So if I authenticate John, and John belongs to 3 domain groups and 2 local groups, isInRole will return true for all those groups he belongs to, and you don't have to write any code for that. That's kind of the default strategy. If you're using something like forms authentication, or if you're doing something customized, you can replace the current principle with your own that implements this yourself. If you do that, there's 2 strategies there. Use generic principle, which says, here's an identity, here's a list of roles, go do your thing. If you can acquire all of the role information up front in one shot, might as well do that. If you need to acquire the role information lazily, maybe you only have an expensive lookup to do if it's requested and maybe it isn't requested all the time, for whatever reason, you want to implement iPrincipal yourself. It's a very easy interface to implement. That's usually the discriminating factor, is whether or not you can acquire everything up front or if you want to do it lazily. Once you've done that, you basically replace the iPrincipal instance on the HTTP context with your new instance, and in effect, you've made your role-based security decision there. So the HTTP context is this state bag that flows around throughout the life cycle of the request. And ASP.NET, if you've enabled any kind of authentication and the user's been authenticated, will populate that for you. Application code with a sufficient amount of trust can replace it with code like the following that basically says, here's my new principal. It might use the same identity and just use different roles. You might choose to use your own identity and use different roles. Basically, the application can control who the principal is and what they belong to at runtime with this mechanism. Okay, I'm going to have one quick demo of how we might do this. We've seen a couple already, and then we'll move on to evidence-based security to finish up. So I've got a demo here that is going to use Windows authentication. And what it's going to do is start off with all my Windows group membership as a basis, and then use a couple of additional application-defined roles on top of that. So if we dump basically all the things here that John belongs to, you can see the normal things like everyone, users, power users. And then I've got some custom roles that I've added down here inside of my application code. You can see that John belongs to custom role 1 and not custom role 2. So let's go look at the code to implement that. We'll start with a look at the iPrincipal implementation first. And for this sample, what I've chosen to do is to inherit from Windows Principal, and my class is called Custom Windows Principal. And the basic strategy here is when you create the class, you give it a list of roles. It keeps that list of roles and it consults those first, and if that role check fails, it delegates to the base class to then resolve against whatever Windows roles you might have. So pretty simple stuff. Just has a string collection here that might have your custom roles, and the isInRole method just looks like this. Consult my own table first. If that fails, just return the base class. And then inside of global.asax, we've got some logic here that basically says, for our test users, John and Mary, we're going to go do some lookups and determine who it is, if it's John or Mary, and figure out what roles they belong to. And then in the unauthenticate event, we'll just go ahead and create a new custom Windows principal. This is that class we just saw. Provide it with the identity. In this case, there's no need to switch that. Windows authentication has already given us an identity, so we'll just reuse it. And we'll call our own business logic here to determine whatever roles the user belongs to on top of the original Windows roles. So custom roles don't have to be based on Windows roles. You can do something completely arbitrary and defined to your application. You do a database lookup to determine what roles a forms authentication user belongs to, for example, or whatever strategy you might have for classifying users into buckets and then treating them differently. This kind of a strategy is a good approach. Okay, we'll finish off here with a look at evidence-based security. Again, this is what code can do, not what the user who's driving the code can do. And the basic idea here is that a web application can be treated differently by using the simple configuration directive. So I might have a shared server, and on that server I might have 10 web applications, and I might decide that those guys all need to be made to play along nicely with each other, and so I'm going to run them all within a given security context. So for example, I might say that this application can only touch data inside of its application hierarchy, regardless of what the operating system allows. Even if I ran everybody as system, we would still only let them touch code inside of their application hierarchy. And then I might decide that this application can go to a database, and this application can go to a middle tier server, and this application can go to a message queue. And I might want to treat them all differently in their set of capabilities. So this code access security lets me as an administrator define what web apps can do, regardless of who's running them, and then at the end of the day set the trust level up so that they can do those sets of things. There's going to be a talk later in the day where Lauren Kohnfelder goes into detail about the whole code access security system inside of the runtime, and it's important to realize that this ASP.NET stuff just sits on top of that. It uses something called application domain policy, which is just a way to say an application can be treated differently from another one. And the way that we expose this is through configuration settings. So there's a setting called trust. Trust has 4 basic attributes that range from full to none, where full trust basically means you're not constrained by code access security. High trust means you're sort of constrained. We kind of trust you. We'll let you touch data inside of your own application hierarchy. We'll let you use databases. We'll let you do some interesting things with reflection. We won't let you call into unmanaged code. We won't let you do some unsafe things with reflection. We won't let you use some other kind of core services that are highly privileged. Low trust is even more limiting. It says that you've got basically read-only access to the system. So no matter what operating system account you're running code as, we're going to constrain you inside of managed code to only the set of things that we deem are safe and only in a read-only fashion. And at the very bottom of the continuum, there's something called no trust, which basically means code can run, period. Can't touch any resources. You can just run code and render dynamic HTML or whatever it is that you want to do, but you can't touch anything on the box. The way that you configure this inside of a web app is using this trust directive inside of the config fragment up here. You say trust level equal whatever, and again the default ones are full, high, low, and none. Administrators can also define their own levels and use them here if they want. And then I can optionally use this thing called origin URL. This works with the web permission, and it's kind of a special thing that says, give me network access to this URL. So if you want to point this at the URL from the site that you're hosting, you can do this. If you want to point it at a middle tier business server to say that I can make remoting calls or web service calls to this place, you can do that. You can do this with policy too, but this is an easy way to configure it. So trust level equal whatever, and the application runs with that sandbox. So we'll show you one sample of how this might work, and then we'll finish up with some questions here. So I'm going to run an application. It's going to try to do 2 things. It's first going to try to read a file and echo it back. So here it's got file access, and it's basically echoed back its own configuration file. And the second thing it tried to do is call into unmanaged code. In this case, it's calling a completely harmless API called getTickCount, but it still needs a very highly privileged permission called the unmanaged code permission in order to do that. So the code for this application looks like this. We've basically got this method here that's going to try to do file I/O. It's just going to use a stream reader and echo back whatever the file is that you hand it. And this other thing just tries to call getTickCount. So very simple stuff. We're running it right now with the following config file, which says that it has full trust, so everything succeeds. So I'm going to go and knock this down to high trust. I'll request the page again. This time I expect the file access still to work because I'm trying to access something inside of my web application hierarchy, so it should work. But this time the native call will fail. So you can see up here for file access, I'm still getting back my configuration file. And this time for the native call, I actually get back an exception, which I've just dumped out here to the page. Let's go knock it down one more time and run it with the no trust level. And this time everything will fail. The app doesn't have file access or the ability to call into unmanaged code, and I just get exceptions back. So the key takeaway here is that as an administrator, you have a lot of power and a lot of control over exactly what your web applications can do. If you want to run a web application with a given set of permissions, you can define exactly what those permissions are and then grant them granularly to individual web applications. So I want to just finish up here by pointing out there are a lot of security sessions going on today and tomorrow. I think some will be of particular interest to folks who are web developers. There's a great session on evidence-based security by Lauren Kohnfelder, which is basically all about the common language runtime security system and how it works. We've got 2 Windows.net sessions, one on authentication, one on authorization, that point out the new things that are coming on those 2 areas. There's a great talk on the future of web services security. So we've seen some web service security today, but we were mostly talking about protecting the protocol, using HTTPS to get there or authenticating people using HTTP. And we'll be seeing some future directions in actually message level security for SOAP and other web service kinds of types. And then finally, Michael Howard will be giving a great session on writing secure code. So if you're a developer and you're just trying to figure out the best practices for writing applications safely, what to avoid, what to get right, you should check out that session and find out how to do it all. Thank you very much for your time today. I appreciate you coming. I'll be sticking around for questions afterwards if anybody has any. Thank you.